This is a demonstration of the four-wheel drive system of a 2007 through 2013 Toyota Tundra. Although this video is specific to the Tundra, the four-wheel drive system shown in this video is very similar to other four-wheel drive systems made by other manufacturers and by other or used in other vehicles made by Toyota. The transfer case is the model JF1A, and it was used from 2007 through 2013 model years. On the back of this transfer case is an electric motor shift actuator assembly that allows the driver to push a button or turn a knob to control which range and mode of the transfer case for four-wheel drive. And then looking at the other parts here, we have the rear output shaft flange. This would go to the rear propeller shaft and the rear axle. We have some internal components here that we'll spend a lot more time on. We have two shift forks inside of here. Toyota calls them the number 1 and the number 2 shift fork. General Motors and other manufacturers, Chrysler, Dodge, would call this the mode fork, and it's for shifting in and out of four-wheel drive. So if that fork is moved forward, that's four-wheel drive. If it's moved back, where it is right now, that's two-wheel drive. This fork over here is called the range fork by most other manufacturers, and it is what puts us in four-wheel drive low if it's moved back, and four-wheel drive high if it's moved forward. Well, moving those shift forks forward and backward is the job of this electric motor pack on the back of the transfer case. And we'll, like I say, we'll get a lot more detail on that here in a little bit. On the front of the transfer case here, this is where the output shaft from the automatic transmission or manual transmission would go, and this housing would bolt to the transmission. Obviously we have a front propeller shaft here that goes to the front axle, the front differential assembly. This is an automatic disconnecting differential assembly. Toyota calls it the ADD differential, automatic disconnecting differential. And it also has an electric motor on the front of it right here, and this electric motor is used to move a shift fork. You can see right there, and move this shift sleeve to the left, which is disconnected, so we'd be in two-wheel drive at that point, or over here to the right, which is connected, which would give us four-wheel drive. And I'll show you how all that works here in just a little bit. I have the right hand CV axle flange without the rest of the CV axle connected to it, inserted into the right hand axle tube, and then I also have the left hand CV flange stuck into the driver's side, the left hand side of the axle or the differential. And as you can see, this CV flange goes all the way in and connects to the side gear in this front differential. This differential on the Toyota Tundra for 2013 is an 8 5/8 of an inch diameter ring gear. It's just a regular open style differential, as you can see. However, looking at the right-hand axle CV joint flange there, it's not rotating, and that's because it is disconnected right here with this automatic disconnecting differential setup. And so we'll talk about how all of that works here shortly. Continuing on around with the rest of the front differential, we have obviously our front propeller shaft here and the universal joints. I'm going to have another video on YouTube here shortly on the proper way to change universal joints. There's a whole lot more to it than most technicians think. And I will show you the official tools and the proper procedures, even selective snap rings to center the universal joints in their flanges. So now let's learn a little more about the transfer case. Okay, we are looking at the transfer case again, but this time the one on the bench that's fully assembled with just some of the material cut away, so you can see the two shift forks move. If you look up inside of there, you can see the sun gear sleeve. I will zoom in here so you can see that. So we've got our number 1 and number 2 shift forks. This one moves this shift sleeve. When it moves it back, will be in 4-wheel drive. Moves it forward, will be in 2-wheel drive. On the other fork, if it moves it forward to the right of the screen, that's the high mode, 2-wheel drive and 4-wheel drive high. If it moves it to the left, then that's low mode, 4-wheel drive low. So let me zoom in here a little bit, get a little better view of what's going on there. It looks like I need a little bit more light. We're going to move both shift forks in the proper order so you can see 2-wheel drive, 4-wheel drive high, and 4-wheel drive low, and then go back. Right now we are in 2-wheel drive mode. The chain is not moving, and I want to move to 4-wheel drive mode. So to go into 4-wheel drive, I'm going to put power on the red wire and ground on the blue. There we go. Okay, you saw that shift fork move, and now we are in 4-wheel drive. The chain is moving, the front propeller shaft is moving. Once we're in 4-wheel drive, then we can engage the front differential, the ADD, automatic disconnecting differential. We can connect the differential and finish the 4-wheel drive process. Now let's go to 4-wheel drive low, since we're in 4-wheel drive high. To go into 4-wheel drive low, I'm going to put power on the blue wire and ground on the black. Here we go. Okay, we've moved to the 4-wheel drive low position. You saw that shift fork move, and now that sleeve is engaged with the sun gear, or not with the sun gear, with the planet carrier. So this sleeve has moved out, or to the left, and you can see the teeth connected to the planet carrier. Now let's go back to the high range and watch those same teeth, and we're going to push them in and connect with the sun gear, which will give us high range and not take advantage of the gear reduction. So here we go. Okay, so now we are in high range. that shift sleeve has moved forward and is no longer in connection with the planet carrier. All right, now to finish off, let's go back to the two-wheel drive mode. So I'm going to put power on the blue, ground on the black, or the red with the blue stripe. Here we go. Okay, so now we've moved back to the two-wheel drive mode. The chain has quit rotating. Once we are in that position, now we can disengage the front differential. The ADD actuator will disconnect those right-hand axle shafts and put us back into two-wheel drive. We do not want the front differential engaged in two-wheel drive because it will force the ring and pinion gear set to rotate, and it'll force the front propeller shaft and the chain and the drive and the driven gears in the transfer case to rotate, all wasting energy and resulting in poor fuel economy. We've talked about the operation of the transfer case back there, but now we have to talk about the operation of the front differential and the automatic disconnecting portion of the front differential. So to understand how all of this works, you first need to understand the two-wheel drive mode of this front differential. So in two-wheel drive, the front propeller shaft here does not rotate at all, because as we saw in the transfer case demonstration a few minutes ago, that front output flange does not turn until that shift fork, the number one shift fork, moves to the four-wheel drive mode. So if the front propeller shaft does not rotate, it's connected to the pinion gear that's inside of this ring and pinion gear set here. Well, if the pinion gear does not rotate, that means that this ring gear does not rotate either. So if it does not rotate, and we've got CV joints, CV drive shafts connected to each front tire, and you're driving down the road, I want you to see that as I rotate both front tires essentially through the CV drive shaft flanges here, that the ring gear does not move. That ring gear right here is solid. So what's moving instead? Well, if you look down inside here, the differential ring, or the differential gear set, is moving. So let me zoom in and get you some detail on that. A little bit more right there. Okay, so we're looking at a side gear, a differential pinion, another side gear back here, and another differential pinion. And notice that as I spin the left front tire forward, that the left front side gear that axle or CV joint flange is splined right to also spins forward. But notice in the back here, the opposite side gear and the axle shaft that connects to it is spinning backwards. Now, you've probably all seen that on a vehicle on the hoist with an open differential. You spin one wheel forward and the other wheel spins backwards. Well, obviously driving down the road, we don't have one wheel spinning forward and the other wheel spinning backwards. So instead, we have to have some sort of a disconnecting differential. So let me zoom back out here. This automatic disconnecting differential actuator assembly here disconnects the whole right-hand side axle shaft from the differential, so that as that side gear spins backwards on the passenger side, it doesn't try to spin the right front tire backwards. So the right front tire can continue to spin forward because this axle shaft is actually cut in two right here. And I'm going to reposition the camera so you can see what's going on here with the cut-in-two part and show you how this actuator moves a little shift fork, moves a little shift sleeve to put that into the four-wheel drive mode. Okay, I've got some better light on that split axle shaft. And once again, here's our shift sleeve and shift fork. If you look up inside there, as I spin this right hand or left hand driver's side CV flange forward, you can see that little set of splines on the little stub shaft spinning backwards. That stub shaft connects into the other side gear on the passenger side. And then this sleeve here connects to the CV flange on the passenger side. So as I spin both wheels forward, you can see we have one spinning backwards and one spinning frontwards. So the only way to connect those two together is to first put the transfer case into four-wheel drive. That will start the ring and pinion gear set spinning, and as the ring and pinion gear set spins, the differentials side gears and pinion gears will stop rotating relative to each other and rotate as one assembly, and then we can move this shift fork over. So I want to show you that shift fork moving. And so I'm going to let me back out here on the zoom. Let me angle the camera down just a little bit so you can see the shift actuator right here. We've got an electrical connection, the electric motor, and it's going to, when I actuate it, it's going to move that sleeve. Go right there. It's going to move that sleeve over to the driver's side and engage us into four-wheel drive on the front axle, front differential. Okay, so I'm going to connect wires to the electric motor for the shift fork right to move this shift fork. So we're going to move this shift fork that moves the sleeve that's going to connect the right hand axle shaft to the right hand axle shaft stub there and put us into four-wheel drive, because right now there's no connection there. So here we go. Okay, we've now moved it to the engaged position. It moved over to the right, and now as I turn the driver's side, the left-hand side CV flange, you can see that the whole right-hand axle turns with it. But that, as I said, should not happen until we are in four-wheel drive on the transfer case. Okay, so we've moved our shift fork and sleeve over into the four-wheel drive position. In order for that to happen, we had to be in the four-wheel drive mode of the transfer case first. So now let me zoom out. And so the entire front differential assembly is in the four-wheel drive mode. Now when that happens, the ADD actuator here, the automatic disconnecting differential actuator, uses two of these wires to notify the computer that the front differential is finally engaged in the four-wheel drive, and that will allow the four-wheel drive light to turn on the dash. On the old manually shifted transfer cases and some of the older vehicles, that switch would physically turn the light on the dash. But on computer-controlled ones, it's an input to the computer, and then a serial data message goes to the instrument panel that then turns on the four-wheel drive light. So one more time, just a quick review. To go into four-wheel drive on just about any four-wheel drive system, we must first shift the transfer case into four-wheel drive. Once that is confirmed that it's in four-wheel drive, then we can engage the front differential into four-wheel drive, and then that will turn on your four-wheel drive light. If you think you're in four-wheel drive but your front propeller shaft is not turning, then you're not in four-wheel drive, and the front differential will probably not be engaged either. To disengage everything, we do not just go opposite directions. We must first disconnect the transfer case from the four-wheel drive mode, and then disconnect the front differential from the four-wheel drive mode. So this has been a demonstration of the power flow and operation of a transfer case and front differential of a part-time four-wheel drive system on just about any four-wheel drive truck out there. This particular one is a 2007 through 2013 Toyota Tundra.